Welcome back to today's Explainer. If you're the kind of person who loves knowing exactly what's going on under the hood of your system, well, you're in exactly the right place. Today, we are going to use a blueprint approach to completely demystify the Linux file system, breaking down some pretty complex architecture into a crystal clear ecosystem. But before we really pull back the curtain, let me ask you this. Where does your data actually live? When you plug in a drive or compile some code, what is that underlying logic keeping the whole shebang perfectly organized?
Well, here is our roadmap to figure that out. We're going to define what a file system actually is, look at Linux's specific rules, run through the different file system flavors, unpack the directory tree, and then wrap up with some essential navigation commands. All right, let's jump right in.
Section 1. What is a file system? The blueprint of storage.
So at its absolute core, a file system is simply the method, the data structure that your operating system uses to store, organize, and pull up files. And this applies to everything, right? Whether you're pulling data from an old-school spinning hard drive, a blazing fast NVMe SSD, or just a cheap USB thumb drive, the file system is that crucial universal translation layer. It's how your OS knows exactly where specific requested byte of data lives.
Section 2. Core Linux features. The rules of the house.
Now, Linux operates on this really radical, actually kind of beautiful philosophy. Absolutely everything is treated as a file. A text document? Yep, file. A directory? File. Your webcam? Believe it or not, also a file. And this entire structure grows out of a single root directory, like a giant tree. It's all locked down by strict permissions and ownership rules, and fortified by journaling. Basically, journaling is a built-in ledger that tracks changes to prevent data corruption before it even has a chance to happen. It's a total game changer. Moving to Section 3, the file system roster, exploring the different flavors. So looking at the native Linux ecosystem, it really evolved through the ext family. We started with the non-journaled ext2 way back in the day, moved up to ext3, which added that crucial journaling feature we just talked about. But the absolute, undisputed heavyweight champion today, that's ext4. It's everywhere. It perfectly balances backwards compatibility with the ability to handle massive files without breaking a sweat. But the ecosystem has specialized powerhouses too. If you need built-in RAID and instant snapshots, you're going to want a modern marvel like Btrfs. Managing massive enterprise-level storage, XFS is absolutely your high-performance workhorse. There's also JFS, developed by IBM, which is super efficient. And hey, while you probably won't see RiserFS much anymore, it was historically a massive stepping stone for journaling tech. And, of course, Linux doesn't exist in a vacuum, right? It relies on cross-platform veterans to bridge the gap. FAT32 is kind of your universal translator for older media. NTFS, that's what lets Linux natively read and write to your Windows partitions. And if you're dealing with modern flash storage and massive files like 4K video, exFAT is what guarantees seamless data transfers across Mac, Windows, and Linux. Section 4, the directory tree unpacked. Navigating the branches. All right, think of the directory tree as a massive, heavily guarded estate. At the absolute base, you have the root directory, represented simply by a /. Nothing, and I mean absolutely nothing, exists outside of this foundation. But nestled safely inside is /home. This is your personal sanctuary. It's the fenced-in backyard where all your personal documents and user settings live, totally isolated from the core system files. When we look at software, Linux cleanly separates the absolute essentials from the extras. /bin holds your core binaries. These are the vital, non-negotiable tools you literally need to boot up and repair the system. On the flip side, /usr is basically your massive toolbox. It houses all the everyday programs and utilities that make your workstation actually useful to you. There's also a really brilliant contrast in how different types of data behave. /edc is pretty much carved in stone. It holds your static, system-wide configuration files that dictate exactly how programs run. But then you have /var, which is the living, breathing pulse of your machine. It holds variable data, most importantly, your system logs, which are constantly writing, shifting, and updating the entire time your computer is on. Now, /tmp is pretty straightforward, acting as a self-cleaning temporary scratchpad. But things get absolutely wild in /dev and /proc. Remember that rule about everything being a file? Well, /dev is where your physical webcam or hard drive literally exist as accessible files on the system. And even crazier, /proc is basically a real-time window into your system's brain. You can read dynamic text files in there to see exactly what your CPU is thinking at this exact millisecond. It's so cool.
Section 5, Essential Navigation Commands, giving you the keys to the house.
Okay, let's get practical. Server suddenly out of space? Run df-h for human-readable disk usage. Just plugged in a new drive and need to find it? lsblk maps out all your physical storage blocks. Typing mount shows you exactly what's attached and where. If a project is hogging space, do-sh gives you that specific folder's footprint. And fdisk-l, that gives you the absolute low-level truth about your partitions. When you actually run these commands, you see the magic of how hardware maps to software. For example, if you see /dev/sda1 map to /home, well, now you speak the language. You instantly know that sda1 is a physical partition formatted with something like ext4, and it is physically grafted onto the /home branch of your directory tree. So we've mapped the blueprint, we've learned the rules, tasted the different flavors, and navigated the branches. Linux gives you absolute granular control over how your data is structured, literally down to the bits on the disk. So I'll leave you with this. Armed with these keys, which file system are you going to trust to architect your next machine? Thanks for tuning into this explainer, and keep exploring.